So, you can see that the cylinder head also contains the valves and the valve mechanism. So, let us look at the valves and the valve mechanisms. Before we go there, like we are going to look at what are called as the intake manifolds and the exhaust manifolds. Okay. So, what are these intake manifolds and exhaust manifolds? So, let us quickly look at them. So, if I want to take an air right from the atmosphere and let us say I have a multi-cylinder engine. So, I need to have a series of pathways right and pipes and other flow paths to take the air from the atmosphere and into the cylinders right in the cylinder block. So, the function of the inlet manifold or the intake manifold is precisely that. So, the inlet manifold essentially is a set of pipes or flow paths right that basically facilitates the flow of air from the atmosphere into the cylinders. Okay. So, that is the function of an intake manifold. So, you can clearly see that I have air being taken what to say from the atmosphere. Okay. So, it passes through a filter or a cleaner to remove dust particles and then like it comes in, and you can see that there is a channel of pipes right or flow paths through which this air is distributed okay, to the respective cylinders. Okay. So, you see that these are the paths through which they go to the corresponding cylinders. So, once again see this picture corresponds to a 4-stroke engine sorry 4-cylinder engine. Okay. So, that is what we have been considering when we looked at the cylinder block and also the cylinder head. So, you can see that there are 4 paths and you essentially go to the corresponding cylinder 1, 2, 3 and 4. Okay. So, in diesel engines like when we come to emissions we will also see that there is something called exhaust gas recirculation, that is what is called as EGR. Okay. We will learn about that later on. Okay. And we will see that even the what to say what comes out of the EGR is routed to the inlet manifold. Okay. We look at it when we come to emissions. Similarly, we have what is called as an exhaust manifold. So, the function of an exhaust manifold is now very obvious right. So, what does it do? It is nothing but a set of pipes that facilitates the removal of exhaust gases from the cylinders. Okay, or the combustion chambers. Okay. So, that is the function of an exhaust manifold. Okay. Right. So, once again you can see that there are 4 paths 1, 2, 3 and 4. Okay. So, through these 4 paths the exhaust gases are removed. And how this intake manifold and exhaust manifold are interfaced with the cylinder? The element that controls and acts as a door between the manifold and the cylinder is the valve. Okay. So, intake valve acts as a door between the intake manifold and the cylinder, the exhaust valve acts as a door between the exhaust manifold and the cylinder. So, obviously they need to be opened at the appropriate time to do the corresponding intake or exhaust process. Okay. So, now we are going to look at valves, which are also like one of the important components in an internal combustion engine. Okay. So, let us look at the valve assembly. Okay. So, which regulate like how these components are interfaced, the manifolds and this one. So, this is a very simple schematic of a valve assembly. So, this is a cut section picture. Okay. Let me also include a schematic, and then things will become clear. So, the valve assembly, what is used in typical automotive applications, by and large we use what are called as spring return valves. Okay. So, by and large in automotive applications we use what are called as spring return valves. As the name suggests, the return of the valve is enabled by the restoring force of a spring. Okay. That is why it's called, they are called as spring return valves. Okay. So, how do they operate? So, in this picture you can clearly see how it works. So, this is our cylinder, okay, and you can see that this is the piston, right. So, this is the cylinder block, this is the cylinder head is shaded in red. Okay. So, you can clearly observe that there is an exhaust valve and an intake valve, okay, which are actuated by these springs and a cam which is connected to what is called as a rocker arm shaft. Okay. We are going to clearly look at this operation in a short time. Okay. So, what happens is that, like, when you want to open the inlet valve and allow air to come into the cylinder, this valve is pushed on. Okay. So, there is an opening which is created here and air starts to flow within the cylinder. Okay. So, that is what happens, okay, when you have the intake valve. And when the intake valve needs to be closed, the contact between the intake valve stem and this rocker arm is removed, and the intake valve goes and closes the gap due to the spring force. That is why it is called as a spring return valve. The same story for the exhaust valve also. Okay. So, if we look at this component, take it apart and have an exploded view of the components, this is what we will have. Okay. So, these are what are called as mushroom shaped valves. So, because this surface of the valve is shaped like a mushroom, okay, it is like a curved surface, right. So, these are what are called as mushroom shaped valves. Okay. So, this is what is called as the valve stem. Okay. And what happens is that you take this valve and insert it from the bottom of the cylinder. So, we saw the bottom view, right, if you of the cylinder head, you just insert it like this. Okay. So, what happens then, the stem comes to the top of the cylinder. So, let us say if this is the thickness of the cylinder head, the stem, part of the stem projects on top. You put the valve seat here so that the valve sits on the valve seat. Okay. The valve seat is put at the bottom surface of the cylinder head where the valve head, this is what is called as a valve head, okay, which is in the shape of a mushroom, will sit. So, the stem will go through the thickness of the cylinder head, and on top you put this, first assemble the spring seat, then what you do is that you put the oil seal, then you assemble these what are called as dual coil springs. There are two coil springs to increase the stiffness of the springs. Okay. You put the dual coil springs, put the spring retainer and assemble everything through a cotter. Okay. So, that is how it is assembled. I hope it is clear how this exploded view is assembled. Okay. So, you insert the stem from the bottom of the cylinder head, the valve head sits on the valve seat at the bottom, then you essentially put this spring seat and the two coil springs, and then put the spring retainer and hold everything through this cotter. Okay. That is how it is assembled. Now, you can immediately see that the spring seats are very important. Why? Because when we analyze coil springs, we assume that if I press a coil spring, its displacement is instantaneous, and if I release a coil spring, once again its restoration is also practically instantaneous. But in real life, we are not going to have that effect, point number one, right. Second point is that although if you hold the coil spring between my two palms, right, if I press it, the displacement will not exactly be along this axis all the time, right. The spring may move a little bit on the surface. So, we do not want that, right, the offset vibrations, right, or the lateral vibrations. So, in order to prevent that and hold the spring in its position, we use the spring seat and spring retainer. Okay. So, those are the main functions of the spring seats and spring retainers. So, let me show you another schematic to clearly illustrate how they are fitted. Okay. So, now you can immediately observe as to how these components are assembled and then actuated. Okay. So, in this schematic, like we show the entire assembly. Let us first discuss this schematic, then we will go to the other one. So, if you look at this schematic, right. So, you can observe that there is this is the wall stem, this is the entire wall assembly. As I told you, this is the thickness of the wall cylinder head, right. So, you can see that the wall stem projects up and then like you hold the what to say springs, right, here, and then you essentially keep them compressed like this. Now, you can have what is called as a cam which directly operates on this wall stem, and then whenever you want the stem to be open, the profile of the cam will change such that the wall stem is pushed down. So, this will open, and when the profile of the cam changes, there will be a small gap which will be introduced between the cam surface and the wall stem, and due to the restoring force of the spring, the wall stem will move up. Okay. That is the function. In some cases, a rocker arm is used, okay. Particularly when you have multiple walls, right, you can have more than one inlet wall and one outlet wall per cylinder. Then you can also use a rocker arm, wherein this is what is called as a rocker arm. The cam does not directly act on the wall stem, but then it acts on the rocker arm which is pivoted here, and then it pushes it. Okay. So, then this end of the rocker arm applies a force on the wall stem and the same action happens. Okay. So, this is how the valve assembly works. Now, there are a couple of important issues associated with this operation. The first thing is that let us say I open the valve, okay, the cam pushes the valve or the rocker arm pushes the valve stem down, okay, the valve is open. Now, the profile of the cam changes such that the contact between the rocker arm or the cam is momentarily lost or the force becomes lower, right. Then what happens, like the spring should push the stem assembly instantaneously, so that like there is a contact, but that never happens in practice, right, because these components are not welded together, right. So, essentially what happens is that there can be some vibrations, right, there can be some impact between the two and that can create some noise. Okay. So, that is present in the spring return valves where you have what is called as some significant valve train noise, particularly when they operate at high speeds. So, how have people solved it? They use what are called tappet valves. So, what they do is that they put what is called as a tappet on top of the valve stem. A tappet is nothing but an oil filled container which is just put there. Okay. So, the contact between the cam or the rocker arm does not happen on the valve stem, but on the oil filled tappet. So, that dampens out the vibrations. Okay. So, it essentially increase the damp. See, this is like a mass spring damper system, right. You have inertia, right, that is why you can't close instantaneously, right. So, you have a spring, a return spring. So, what people do is that they introduce a damper, and as we know from our basic dynamic systems also that if you put a damper, and you increase the damping ratio, the oscillations will be subdued, right. So that is what people do, right, by putting a tappet. Okay. So then what happens is that there is another issue. Okay. So what is the next issue? If you keep on increasing the speed, as we discussed, at 3000 rpm for the crankshaft, we had 10 milliseconds, right, for the valve to open and close in one stroke, right. So let us say I increase the speed, like let us say to 4000 rpm. Now what is going to happen? How much time will I have? Around 6, what to say, now the thing will reduce by 30%, right. So I will have, sorry, 33, 1/3, right, I will have 2/3 of the time, right, to essentially do the opening and closing operation. Now you see that it has decreased. So just to take round numbers, let us say I increase from 3000 rpm to 4500 rpm, that means that I have increased by 50%. So what is going to happen? 10 millisecond also is going to decrease. So in other words, if you increase the speed, the time available is going to decrease. So what happens is that you need some response time. See, as we also learned from our dynamic systems course, like that, even if you have a mass spring damper system, there is a rise time, there is a response time and so on, right, things do not close immediately. So what happens is that, like, as the speed increases and the time available for your opening and closure comes down, your valve may be commanded to open the valve assembly, the camshaft, the cam will be commanding the valve to be open, and it will command it to close, but before it closes completely, the next cycle will start. The control mechanism will say, oh hey, open the valve once again. So what will happen is that an issue called as valve float arises. Okay. So what is valve float? That is, the valve will seem to be floating, that is, it never closes completely and never opens completely, because by the time it opens, it goes to opening completely, the command has reversed to closing it, but the time it starts to close, the next cycle would have started and it would have been commanded to open. So that is going to be, what to say, a challenge, right. What people can do, that is have done, you can never eliminate valve float in the spring return valves, because that is how they work, right, it is inherent to them. So what people have done is that, like, they have increased the stiffness of the spring. Okay. People can either use high stiffness springs, you replace springs when they become soft with operation, you can increase the preloads, as you can see in this before and after curve, right. And then, like, people also introduce these shims. Okay. Shims are nothing but accurately machined washers, okay, on which you mount the springs, so that you even avoid any lateral vibrations, and then you ensure that the, what to say, spring does its operation very optimally, okay, as far as restoring the valve to its original position is concerned. Okay. So all these tools have led to the reduction in valve float, okay, but in a spring return valve you can never completely eliminate valve float. Okay. So that is a limitation. Then if you want to completely eliminate valve float, what is it that we can do? We have to use a different closing mechanism, right. See, because imagine a door, for example, most of the doors that we have today are these automatic closing ones, right. So let us say I open a door, I grip the handle, I pull the door open, right. So then what happens, if I go outside, I leave the handle and the door closes slowly. But on the other hand, I want to close the door also fast enough. What do? I can grip the handle on the other side and pull it, right, not depend on any spring or any automatic closing mechanism and so on, right, same story. So what happens is that there is something called as a desmodromic valve, okay, used in a very few road vehicles where you want very accurate control, particularly at high speeds and so on, okay, what is called as a desmodromic valve, okay, desmodromic, okay, valve. So what happens is that in a desmodromic valve you do not have this return spring, but you will have a rocker arm for pushing it down, you will have a rocker arm for pulling it up. Okay. So, in both sides you will essentially open and close the wall without a spring, because with a spring you have compliance and then you have these dynamic effects coming in, right. So, essentially when you have this rigid contact, right, you can push and pull to the best possible extent. Okay. So, that way this desmodromic wall uses a rocker arm to essentially both open and close the wall, okay, and this eliminates wall float. Okay. So, this mechanism essentially can completely remove wall float. Okay. So, we have looked at the valve assembly. We will continue from here in the next class and then like look at other components, you know, like camshaft and other components that make up an engine, and then we will continue, right. Okay. Thank you.